Hello, I'm Frank Marchlinsky from Philadelphia, Pennsylvania, and with me is Dr. Pierre Jaïs from Bordeaux, France. Welcome, Dr. Jaïs. Okay.
Thank you.
We're here to talk about a new form of energy delivery that maybe provide us improved outcomes and efficacy in patients with atrial fibrillation and perhaps other arrhythmias, so-called pulse field ablation.
Yes.
Why don't we start by telling the audience about pulse field ablation? How does pulse field ablation differ from typical thermal injury ablation techniques?
Yes, thank you, Frank. It's very different, and I think it's really critical to understand these differences. So electroporation is current delivery to tissue, but it's very different from radio frequency, which is constant current. Here we are delivering pulses of high voltage to the tissue. And so this is not producing any significant temperature increase, either at the level of the electrodes or at the tissue. And the mechanism is completely different and original. We are in fact opening holes in the membrane, in the cardiomyocyte membrane. And this is going to ultimately kill the cells that have been within the field that we have generated. So this notion of volume in field, electrical field that is generated is key to understand how it works. And so this volume where the current is above the threshold of the cardiomyocytes will determine the lesion in the heart. So we're very lucky here because the heart cells are very sensitive to electroporation, unlike the surrounding cells from the phrenic nerve or esophagus, for example. So if your field is over a threshold that has been determined to be about 400 volts per centimeter, whatever, everything that is in that region is going to be killed by the energy. And you don't even need the electrode to really be in contact with the tissue. If you are off by a few millimeters, it will not significantly impact the lesion. So it makes it very forgiving and easy to use.
And it is specific for an effect on myocardial tissue, or does it damage other tissue in the process? Why is it, so you don't have to be in contact, that's obviously a plus. But are there issues related to the tissue specificity that really are dramatic?
Yeah, it's a very interesting property of there are probably multiple reasons for that. The shape of the cells, for example, is one of them. And the fact that the cardiac cells are polarized plays also an important role here. But the thing is that they are extremely sensitive to this energy, and you would need 4 times higher energy delivery to start impacting the phrenic nerve. And the esophagus is even more resistant than that. And the fact that it's non-thermal by itself, I think, is super interesting as well. Because you know that we have some issues with the fact of burning the tissue.
Disruption of tissue.
Disruption of tissue. The architecture is completely changed. We may even create some retractile healing in the myocardium, which is probably not a good thing. Stiff LA syndrome is something I fear, even if it's rare. So I'm happy we don't have that. Pulmonary vein stenosis, of course, is also attached to this thermal component of both RF and cryoablation. And I also have the feeling that because it's a volume effect of the electrical field, it's very forgiving. So you place the catheter in the pulmonary vein ostium, and you get the isolation without having to finely refine your positioning. And with cryoballoon, you have to sometimes do some maneuvers like pull back the catheter during once the ice ball is formed to occlude a infield leak, whatever. There's nothing comparable here.
But you pointed out it's contact with thermal. And once you've moved beyond contact, but just get a reasonable proximity, it's almost too good to be true that you're able to alter the tissue or damage the tissue that you want to very selectively.
That's amazing.
The real most amazing thing, right, as you said, is the difference between myocardial tissue and surrounding tissue. Yeah. I know as electrophysiologists, we live in fear of doing harm, right? So whether it's esophagus, phrenic nerve, making stenosis occur from being too aggressive with other injury techniques, having a technique that limits that. Is it limited, or just really does it look like it's not doing it?
I'm really confident we will have no esophageal concern or injuries. And the reason for that confidence comes from the animal studies we did, where we did deliver right on the esophagus. I mean, not even for the cardiac wall, directly on the esophagus, and we've seen no change at all at the with the waveform characteristics that we use to kill cardiomyocytes.
Yeah, so that's pretty amazing.
Yeah, I think, and we did some, of course, some ablation in patients as well, and some of them have been almost randomly. I mean, it was based on availability of this test. Some of them had direct esophagoscopy. We've seen no lesion. Others have had MRI. We've seen no late gad enhancement of the esophagus, and that's very different from what we see acutely when we're doing RF or cryo.
Right, and how about the phrenic nerve? Because we've worked to, we always have hesitation about balloon technology of any sort because that fixed positioning, and we have to work around where we identify the phrenic. Is it really, again, the myocardium versus the phrenic nerve appears to have a distinct difference in terms of the threshold for creating this injury?
It seems, yes. The safety margin is, I think, really significant. Interestingly enough, when you deliver for the right pulmonary veins, you are going to capture the phrenic nerve. So you see the diaphragm contracting, but this has never translated in any injury of the phrenic nerve. So we test that right after the procedure and never seen any change.
So the pulse field ablation can stimulate, but doesn't cause the pores to form, the nanopores to form that can cause the cells to die.
Yeah. It's electrical capture, but it's not doing any harm.
Yeah, that's an important feature. So tell us about your clinical experience. What have you been doing with this pulse field ablation?
So,
what kind of tools you've been using?
Yeah, so the tool is here. And it's interesting because it's almost the same tool since the beginning. The generator is missing here, and that's the critical component. Because we've been starting with monophasic, and got a lot of muscular stimulation. Particularly the animals at the beginning of the experience were jumping on the table when delivering. We had to use paralytic agents. And the first patients were done with this energy as well. And we had so many iterations in changes in the waveform, so that at the end we could finally use biphasic, bipolar, with no need for general anesthesia, no need for paralytics. It's only a conscious sedation. So we would typically inject 4 or 5 cc of propofol to begin with, wait for the patient to be disconnected, and then deliver. And basically this is the tool. It's an over-the-wire. It comes with a sheath, of course, that we don't see here. And it's pretty much like a balloon. And you see, we would cannulate the vein with the wire. And I like this basket configuration very much because it's, I think, associated with a pretty easy deployment in very straightforward procedure, typically. Some veins are big enough to require the alternative deployment that is what we would call the flower, and so this now is the...
it's a little bit flatter and a bigger diameter?
Yeah, it's all in the equatorial plan. And you see it's a much bigger diameter, so it might be of interest in some big veins.
some of those left veins that
Yep.
the osteum can be quite large.
common os, etc.
Yep.
But again, even if some electrodes are a little bit off, like a couple of millimeters, definitely 2 millimeters gap doesn't matter. You would get your lesion very nicely.
So with that flower configuration, do you need routinely more than one lesion application to isolate the vein?
We always need more.
Okay.
Repetition is an important parameter of the recipe for successful and durable isolation of the veins.
Right.
So this varies, and we're still working for the lowest amount of repetitions that we need to achieve durable PVI. Present time we're using 8 per vein. It's going to change. It will be less than that in the near future, I'm confident. But repetition is an important parameter.
So you've varied the repetition to some extent. You've varied the energy delivery and monophasic, biphasic. And yet, with all that variability, you're still within that safety zone to do no harm.
That's correct.
And that's really an important issue, isn't it?
Because it is.
You know, you've pushed more energy, you've delivered biphasic, monophasic, and despite those changes, at least the safety issues have been hopefully off the table, but at least with the clinical experience you have, you're confident, very, very low risk.
I agree. It's what is striking with this energy. Now, again, there are so many parameters you can play with when it comes to energy waveform and characteristics. That, for example, if you were using waveforms that have been used for defibrillation, you may end up with some thermal effect.
Of course.
It's, I mean,
you still have to be smart about the selection. And there still needs obviously an ongoing evaluation to optimize things.
Exactly.
Yeah, which makes sense to me. Now, so what has been the clinical experience in terms of vein isolation and clinical control of AFib with this technique? Have you have any preliminary data to share with us? Yeah,
of course. So it's very interesting when we look back at the earliest experience. It wasn't that good. I mean, when we started with the monopolar deliveries, in addition to the clinically more cumbersome workflow, we had some reconnections that were, in fact, the majority of patients. Now, the unique thing, it's not unique, but the rare thing we did, which I think is good and should possibly be considered for any new technology for PVI or any type of lesions, by the way, but PVI is very straightforward, is to systematically assess at 3 months. I think this is fantastic. I mean,
that's a rigorous thing. It was always hard. I'm not sure whether we're going to be able to do it in the States because of the regulatory bodies, but we certainly would love to be able to at least consider it. I mean, it's for patients that are willing to have it done.
But the thing is that we learn so much.
Sure.
Because you know, as I do, that there are so many reasons for failing clinically at 1 year that you don't really know if you failed because your strategy wasn't good or because your lesions were not durable. So at least we know that.
I've been a big believer in that. Always, if you got to get those veins to stay isolated, you got to, if you can prove it with a technique.
It's the first thing to do, and we've been confused by PV reconnection and lesion instability, and for the first time, we have something here that gives us 100% stability at 3 months. Now again, this is not something we achieved at the beginning. We were 18%. And by changing, refining, etc., we ended up with the last 20 patients in our experience, 20 consecutive patients, had perfectly stable lesions at 3 months. This is very encouraging.
And you've published your results now in terms of the journal article?
This has been published in JACC this year,
very nice.
2019.
It's something to be proud of. Seems like it's going to influence the field in terms of its potential.
Definitely. I'm really fascinated. So it's fast. We haven't talked about that, but it's super fast. I mean, last patient I did was 12 minutes in the left atrium. So you get to the vein, deliver, move to the next, etc. You can record from these electrodes. One of these electrodes, the equatorial one, allows you to record. So it's pretty easy to know whether the vein is isolated or not. There's no need for systematic remapping. We do it because we like to have a very clear documentation and compare the acute to 3 months.
Sure.
But you don't have to. So it's super fast. It's creating durable lesions, and it's super safe.
Right.
I mean, unprecedented safety.
Right. Yeah, no, again, I
Interesting.
think that, the movement with all technologies is faster. Some of it comes with a higher energy delivery, but with any thermal injury, energy delivery, we always have to worry about safety. And we've worked very hard to minimize that safety. I mean, you've done it, we've done it. It's important to recognize, of course, that those techniques have gotten safer and faster. So
Definitely.
it's a challenge, but it's, again, if you have the guarantee, even if it's a small amount,
That's the
and you have
point.
the guarantee, you begin to go as a caregiver and one who's doing these procedures.
You're exactly right.
I don't want to think about it if I don't have to, right? I mean, even if it's almost zero, you got to make it zero.
Well, clearly, if you ask me if I'm having atrial fibrillation one day, I'm happy to come to you for an ablation, but please use electroporation for me.
Yeah, I understand that. All right, well, listen, this is a lot of valuable information for the EP community. I've certainly enjoyed talking to you as always.
Thank you, Frank.
Okay, thanks.
Fantastic.
Okay.
Thank you.
Thank you.